about this one. This one is simpler, and I can probably demonstrate it without following it up. This is an auction. So let's make the auction.sol contract. And there it is. I'm going to delete it and put in the code again. All right. So here's the actual auction. It has a public address. You can, these are public variables anybody can see stored on the blockchain. The address of the current leader, the highest bid, and there's an event to log bids that I added, which is not really important. Here's how you bid. It checks to see if the value of money you're sending in is greater than the highest bid. If it is, it then refunds the highest bid back to the current leader, and it requires that that succeeds. This will refund the old leader. If it fails, then cancel everything. Then the current leader will become the person who sent this, and the highest bid will become that value. That's what you send in your money, and somebody has to send in more money, and they then replace you as the leader. That's the auction. So let's compile this. All right, it compiled without errors, or just 2 warnings I don't care about. And now let's see, I don't have any junk on my blockchain. Got a nice fresh simulated blockchain, so I can just deploy this. Now, this is trying to deploy the attacker contract I haven't discussed yet. First, you have to deploy the auction contract. The auction contract, all you do is hit deploy. It works, and now you have an auction down here. So let's use this thing as intended for a while. So I'll go to the first account, which is where I am, and I'll bid, say, 1 Ether. Okay, so I bid, and it's done, and now the current leader is 5B, which is me, 5B, and the highest bid is 1 Ether. So now if I go to the second account, and I bid 2 Ether, all right, now the leader has changed, and the winner is now 2 Ether, so this is working just the way it should. Now we're going to cheat. We're going to put in the attacker's contract. Now the attacker is a contract that attacks another contract. So it has a parameter, which is the address of the auction contract. And so when you deploy attacker, you have to give it the address of the auction contract, which is down here. So I copy that and put that in and deploy it. And that succeeds. So now I have a second set of buttons down here called the attacker. And that has a function called win. And the way it works is extremely simple. It has this unnamed function here, which is payable external. This is what happens when you send money to a contract. If you don't define a receive function, it will go to this default function here called the fallback function. Anytime you call a function that it can't reach the right function, it will just go to the fallback function, and the fallback function reverts the transaction. So if you try to send any money to this contract, it will refuse the money and cancel it. And that means that this contract will never get past this point. It cannot refund my highest bid to let the next person who bid more get in. It will stop at this point, so I will always win the auction. So now I go to the third person and win. And now I want to see if that worked. I want to roll this up so I can see. It failed. All right, I'll have to check my instructions. All right. Deploying the auction card, deploying the attacker, good. Using the auction, which we did. Making a higher bid, which we did. Okay. Now we attack it. So we go to the third account, enter 3 Ether. Oh, I think I forgot to put in 3 Ether. That's why I had to have a higher bid. Yep, I forgot to put in 3 Ether. You do have to, of course, bid more. 3 Ether, and now win. All right, now I've won. Now the highest bid is now 3, and the address, this is an important fact. The address here is 652, but my address is 4B2. So when I bid, the money does not go to my account. It goes to the account of my attacking contract here, 652. That was the one that's winning. And one thing that's missing here is I'd have to add a withdraw function so I can withdraw the money later. But anyway, this shows the point. And so now this is winning. And now if anybody tries to bid higher than me, like here, if the first person tries to bid 4, not 40, but 4, or although 40 would work as well, and they bid that, it cancels and reverts, and they do not become the leader. The highest bid remains 3, and the current leader remains my contract. So that is a simple logic flaw in this that you've exploited. And of course, you can fix it. And I think I've got the fix here. And yep, that's, okay, here's the fix. Just removing the require from that would do it. So let's do that. Let's make a contract where this attack will not work by changing the auction not to require this. So instead of requiring that you return the current leader money to take a new bid, it's just going to attempt to return the current leader's money. And if that fails, it will just let them lose their money and move on to the next person. So I changed this. Let me go back to here, back to London to clean off my blockchain. Go back and compile it again. Now deploy it. I deploy the auction, get the address, and deploy the attacker. All right, and now if I bid 1 from the first account, 1 ether from the first account, I bid. So now the current leader is that, and the highest bid is 1. Now I try to cheat by going to the second account and bidding 2 ether, and go down to my attacking contract, which I don't see. Somehow I failed to deploy it. All right. Here's my auction contract. I copy it. I deploy my attacker contract. Okay. I do have my attacker contract. And so now I think I paid 2 ether to deploy it by being clumsy here, but anyway, 2 ether from my second account to win. Okay, and that worked. So now my contract address A13 is now the leader, and the highest bid is 2. But, and this contract, all right, now if I try to bid 3 from the third account, it works, and now the third account's winning. And I didn't get my 2 back, so that's all that happens. This is now fixed, so you can no longer cheat with that attack. And all the ones, the projects like this, we're going to show you that the fixes are included in most of them, perhaps all of them. So I'll stop that.